All right, so today we're going to pull back the curtain on the core recipe that powers so much of our modern world. It's called the machine learning lifecycle. This is the step-by-step process that turns, just raw data into these incredibly intelligent, predictive actions that we see every day.
I mean, have you ever really stopped to wonder how Netflix just knows what movie you want to watch next? Or how your email inbox is, for the most part, magically free of spam? It's not magic. It all comes down to a single, really powerful workflow. And by the end of this, you're going to understand exactly how that process works, from start to finish. So what is this thing really? Well, put simply, the machine learning lifecycle is just the structured path you take to get from an idea to a working AI model. And to make it all click, we're going to think of it just like cooking a gourmet dish. You need a clear recipe, top-notch ingredients, some careful prep work, and of course, a final, perfect presentation. Every amazing meal starts with two things, right? A clear recipe and the right ingredients. In machine learning, that recipe is your problem statement, and the ingredients, well, that's your data. And believe me, if you get this part wrong, the whole thing just falls apart before you even begin. Okay, check this out because this slide shows just how much clarity matters. A vague goal like predict student success, what does that even mean? It's kind of useless. A good problem statement is super specific. Predict whether a student will pass or fail using their study hours and attendance records. See? It defines our inputs and exactly what we want as an output. This is our recipe card.
So, with our recipe in hand, we need our ingredients, the data. And this stuff can come from pretty much anywhere. Simple Excel files, massive databases, APIs that let different apps talk to each other. We can even scrape it from websites or track user clicks. For our student example, we might grab attendance from one system and study hours from another. The main goal here is just to gather all the relevant ingredients for our dish.
And now we get to what a lot of data scientists will tell you is like 90% of the job, the prep work. Because just like in a kitchen, you can't just throw raw, messy ingredients into a pot. You have to clean them, chop them, and get them ready first. So this is what data looks like in the wild. It's a mess, right? We've got missing values here, totally inconsistent formats there. Maybe someone wrote an age as 22 instead of the number 22. You absolutely cannot feed this mess directly to a model.
And bam, look at the difference. After cleaning, the data is standardized, it's complete, we've handled those missing values, the formats are all consistent, and everything is ready for the next stage. It's beautiful. We now have a set of perfectly prepped ingredients.
There's a famous saying in computer science, and it is so true here. Garbage in, garbage out. And the point is, a machine learning model is only as smart as the data you give it. If your data is flawed, the patterns it learns will be flawed too. Simple as that. The quality of your prep work is going to directly determine the quality of your final dish. Now, part of this whole prep phase is something called exploratory data analysis, or EDA. This is where you really get to know your ingredients. You make charts. You look for patterns and relationships. It's exactly like a chef tasting the broth for saltiness or checking how sweet the tomatoes are before they even start cooking. It tells you what you're working with and informs every decision you make next. And through EDA, you might find an amazing aha moment like this one. This chart makes it crystal clear that as study hours go up, the pass rate goes up too. This confirms our hunch that hours studied is a super important ingredient for our recipe. It's going to be a really powerful predictor in our model. All right, our ingredients are prepped, and we have a really good feel for them. Now for the really exciting part, the actual cooking. This is where we take all that beautifully prepared data and use it to train our machine learning model. But wait, before we start training, there's this really clever step called feature engineering. Think of it like some advanced culinary technique. Instead of just using a raw date of birth, which isn't that helpful, we transform it into a much more useful feature, age. It's like grinding spices to bring out their flavor. It just helps the model learn better. The training process itself is kind of like trying out a few different cooking methods. These methods are called algorithms. So we might try one algorithm that's really good at predicting a specific number, and another one that's better at sorting things into categories, like pass or fail. We feed our data to each one, let them learn the patterns, and then we check to see which recipe gave us the best results.
So, our model is trained. The dish is cooked, it smells amazing, and it tastes great in our test kitchen. But the job isn't done. Now we have to plate it, serve it, and make sure it stays just as delicious over time.
So, we test our final model on some new data it's never seen before. And the result? 92% accuracy. That sounds amazing, right? Looks like we can pack up and go home, job done. Well, not so fast. A high accuracy number like that can actually be pretty misleading. For example, what if our original data had very few students who failed? The model might get really good at just predicting pass all the time because it's common, but be terrible at spotting the students who are actually at risk. So yeah, evaluation is a lot more nuanced than just one single number. Once we're actually confident in our model, we deploy it. This is literally serving the dish. We integrate the model into a website or an app so that real people can get predictions from it 24/7. It's no longer in our private kitchen. It's out there, in the world. But here's the thing. The world changes. What if the school introduces a new online learning tool? Student study habits could change completely. This is something we call data drift, where the new data from the real world doesn't look like the old data the model was trained on. So we have to constantly monitor performance. If we see that accuracy start to drop, it's a huge sign that our recipe is outdated, and it's time to go back and retrain the model with fresh ingredients. And that brings us to the most important takeaway of this whole thing. The machine learning lifecycle isn't a straight line that you just finish. It's a continuous, repeating cycle of building, deploying, monitoring, and going back to improve it. The learning never, ever stops. So, there you have it. From defining the problem to constantly monitoring the result, that's the full recipe for building a machine learning model. It's an incredibly powerful workflow that transforms data into decisions. The only question left is, what problem would you solve with it?